Today's lesson is about transformations. It's really intended to be a review lesson and an overview of ideas that you should have already learned. So if you're unfamiliar with transformations, this is not a great starting point. It's a great refresher on skills and things that you hopefully already know. So when you're performing a transformation, the acronym that I learned is HI-VO. And that acronym just helps me remember what's going on where. The HI, H-I, stands for the horizontal things are happening inside, and they are the inverse or the opposite of what you think they should be. The VO part is the vertical. The vertical is happening outside, and it is the original. It is what you think it is. And what do I mean by that? I mean, for vertical, if it says +5, that means up 5. That is what you think it should be. As opposed to horizontal, if it says +5, it actually means not 5 to the right, but 5 to the left. So it's the opposite of what you think, or the inverse of what you think it should be. So there are a couple of types of transformations. There are rigid transformations, which means that we aren't changing the shape or the size. We're simply shifting it. It's almost like we're picking up whatever we're talking about and we're moving it somewhere else on the paper. And if you think about shifts, like translations, we're talking about moving left, moving right, moving up, moving down. So if we're talking left or right, that's happening inside the function because that's horizontal movement. Left and right is horizontal. So you will see that happening with x inside parentheses, not as something else happening on the outside. So for example, f of x plus 3 or f of x minus 3. X plus 3 would be 3 to the left, and f minus 3 would be 3 to the right. The opposite of what you think. Now, if we're talking about up and down translations or vertical movement, we're talking about a plus k value, and notice that that k is not inside with x, it's on the outside. So we're taking the entire function and we're adding some number. That would mean that we're moving up 3, or we're taking that entire function and we're subtracting that number. That would mean that we're moving down that many spaces. So these are rigid transformations, translations are, that move our function left, right, up, and down, depending on how it is written. Now we're going to talk about stretches and shrinks, which are examples of non-rigid transformations because they do change the shape and the size of our functions. So again, horizontal is happening on the inside of our function, so something like f of 3x. And where you might think that that would be stretching something, this is actually a horizontal shrink of 1/3 because it's happening inside and it's the inverse of what you think it should be. Versus if I had f of 1/3 x, this would actually be a horizontal stretch of 3. And when you're thinking about these horizontal stretches and shrinks, what I want you to think visually is that you're taking the x-axis and you're shrinking or you're pushing it together versus pulling it further away. And that'll help you get a visual understanding of what's going on with the function. Now, if we're talking about a vertical stretch or shrink, that value, again, is going to be happening outside the function. So we're taking the function and we're multiplying it by some constant. So 3 times f of x would be a vertical stretch of 3. 1/3 times f of x would be a vertical shrink of 1/3. So it is what you think it would be. Again, to visualize this vertically, think about the y-axis. Think about what you would do if you stretched the y-axis versus if you pushed it together. Think about that to help you understand what this would look like graphically. And then the last thing down here, the other kind of transformation we're going to refer to are reflections. Typically, when we're talking about reflections, we're going to focus on reflections that either happen in the x-axis, which means that you're taking the opposite of the entire function. So you are changing y. It happens to everything. Versus reflections in the y-axis. So this was x-axis versus reflections in the y-axis where you're actually substituting in negative x for x. You're plugging in negative x everywhere there was an x. That would reflect over the y-axis. So now that we have reviewed what these transformations are, let's get to some practice problems and see how do we use them. All right, for these first 4 examples, we are going to describe in words what is happening to each of these functions f. So for number 1, this negative in front of the function. So notice nothing is happening inside with f of x. Nothing is happening inside, which means these are all outside transformations, which mean they're all happening vertically. So this negative sign is a reflection over the x-axis since everything is changing. And this +2 means that it is then translating up 2 units. Looking at number 2, however, everything that's happening is happening on the inside. So that means this is horizontal. So why don't you go ahead and pause the video and see if you can identify what this changes on number 2. So hopefully you had enough time to pause the video. This is a translation since it's -2. Since it's horizontal and it's happening inside, it's going to be the inverse of what I think. So it's going to be translating 2 units to the right. If you're feeling pretty confident in this, go ahead and pause the video and try and work on 3 through 4. Otherwise, you can follow along with me. So here we go. I'm going to talk about stretches and shrinks first. So this right here is a vertical stretch with a scale factor of 2. Then we have some translations happening. We're translate left 1 and down 1. So each thing that's different from this just being plain old f of x, each difference is a transformation that you're going to describe in words. Go ahead and pause the video and try and work through number 4. All right, this negative x means that we are reflecting over the y-axis. -3 means we're translating 3 to the right, and this +1 means and 1 up. So now that we've talked about describing the transformations in words, we're going to move to actually performing those transformations. So we're going to start with the words and we're going to work backwards to try and write what that looks like to a function f. Okay, so number 5, I have my function f. It is translating 4 units to the left. That's horizontal, so it's happening inside. 4 to the left means +2, and then down 2 means -2 out here. Oh, 4 to the left, not 2 to the left. Let's make that a 4. There we go. 4 to the left and down 2. Go ahead and pause the video and work through number 6 on your own. All right, we are reflecting over the y-axis, which means we're going to have a negative x here. And translating 1 right would mean -1. And 2 up would mean +2. Now that we've spent some time looking at the equation or the function side of this, let's spend some time actually focusing about transforming graphs, because again, the big piece in this entire unit is how do we understand how a graph behaves, what it looks like, and these transformations help us understand how it differs from its original parent function. So let's look at some graphs. So here we have a graph, and we're going to call this graph G, and we're going to be asked to sketch a transformation of the graph G on the same axes. So here we have our transformation. Let's go ahead. Actually, why don't you pause the video and describe that transformation in words? And there we have that transformation. So we're going to have to create a new graph where we take the graph that we see, we reflect it over the x-axis, and we move it up 3. And some people have a great visual spatial awareness and can do this without really having to show any work. For me, I need some tips to help me along the way, to help me sort through my thoughts. So here are my tips for you. The first thing that I want you to do is I want you to think about a few key points. So in this case, we're going to use these 3 key points as the points that we're thinking about. Don't forget about your high-vo, and make sure that your new graph makes visual sense to what you're saying happened. Does it actually look like I flipped it over the x-axis and moved it up 3? And what I'm going to do for this first example is I'm actually going to make a table so that you can see a worked out version of sort of how to mathematically justify this for yourself. But again, this is not the only way to do it. It's just a way for those of you that don't have great spatial awareness or aren't great at doing this in your head. So what I'm going to do is I'm going to make a table using the 3 points that I see in the graph. So I see the point -2, 0, I see the point 0, 2, and I see the point 2, 4. Then I'm going to add a column to my table that is the transformation. So negative g of x plus 3, that's what I'm going to do to each of my g of x values. And then I'm going to just make a last column which has my new points that I'm going to graph. So something to keep in mind, my goal is to get 3 new points so that I can graph these 3 points and connect them with a curve that looks like what we have here. My 3 new points are reflecting over the x-axis and they're moving up 3, which means nothing is changing with my x values. There's no horizontal translation here, so my x values are still going to be exactly the same. If my x values were changing, let's say it was g of x plus 1, then all of these x values would change. However, that's not the case on this particular one, so we get to keep our x values the same. So what are we doing? We're taking our g values, we're taking the opposite of them and adding 3. So here I was at 0, the opposite of 0 is still 0, plus 3 is 3. I'm taking 2. The opposite of 2 is negative 2, plus 3 is 1. I'm taking 4. The opposite of 4 is negative 4, plus 3 is negative 1. So now I have 3 new points that I can go ahead and graph. Now here's the part that's a little tricky. When I graph these 3 points, they kind of look like they make a straight line, but they definitely shouldn't because they should follow the same form that this follows. So you're going to do the best that you can to create the same curve. So I'm thinking about creating this curve that connects the points and looks somewhat like what my original function looked like. All right, let's go ahead and look at a couple more examples. All right, why don't you go ahead and look at 7 and 8 and identify in words what those transformations are first. So go ahead and pause the video and do that. So here are my described transformations. The next thing I'm going to have you do is identify 3 or 4 points on the graph, like plot them as points so that you can think about how you're going to transform those specific points. Now, if you wanted to set this up using a table, you could have your x, you could have your f of x, you could have your f of x minus 2, because the horizontal component is going to come in over here, and you're actually going to add 1 because horizontal happens inside, and it's the inverse of what you think it should be. So you could just translate each of those points in this way. So what I mean by that, I'm going to pick an easy point. I see the point 0, 1. If I went down 2, so 1 minus 2 would get me to negative 1, and I went right 1, that would make my x value, which was 0, now become 1. For something like a translation here, this may be more complicated. It might be easier for you to just say, I'm going to take this purple point right here, I'm going to move it 1 to the right, and then I'm going to move it down 2. So down 1, down 2 would put me right here. Similarly, if I took this point at 0, 1, if I move it 1 to the right, I would be at positive 1, and then I go down 2 from up 1, that would put me down here. That would be my second point. Why don't you go ahead and pause the video and see if you can do the same thing for the next 2 points. All right, so this point, 2, 2, if I move down 2 puts me on the x-axis and right 1 puts me at the point 3, 0. And last but not least, this point here, if I move down 1, 2 and over 1, I am here. And now I'm going to do my best to connect and keep the same shape on my new transformed graph. Now remember, it kind of looks like a line until I get to this point, and then it sort of curves a little bit like a parabola. So keep that in mind when you're connecting. And there we have it. All right, go ahead, whether you need to use the table or you want to do it without the table, go ahead and work through number 8 on your own. So I listed out those 4 ordered pairs here. And again, there's nothing happening horizontally, so my x values are going to stay the same in my new ordered pairs. No, you don't have to write these out as points. What's happening to my y values? Well, they're going to change sign, and then I'm going to add 1. Change sign, add 1. So 1/2 is going to become negative 1/2, and then I'm going to add 1, which is still going to give me 1/2. So this point's actually going to stay in the exact same place. If I'm at +1, if I change sign, that's going to become -1. If I add 1 to -1, I get 0. Let's use a different color here. So 0, 0. 2, if I change the sign of 2, it becomes -2, and I add 1, I get -1. So 2, -1. And then lastly, in the 0.31, I'm looking at the y values here. So I'm going to change the sign of my y value to make it -1 and add 1. That gives me 0. And then I'm going to connect. And again, after you finish sketching these new graphs, you need to ask yourself, does this look like what I said it was going to? Does this look like it reflected over the x-axis and then moved up 1? It totally does. So we're going to look at one last example, and then we're going to recap what we learned in this video. All right, now we are being given the graph of two functions, and we're being asked, how do we get from f, the top one, to g, the bottom one? And again, there's a lot of different ways to do this. So what I'm going to do is I'm going to focus on just one point first. The point 2, 2 is on F. And that point very clearly goes down to become the point 0, -2 on G. So I'm going to ask myself, I'm going to look at what I see visually, and then I'm going to make sure that mathematically what I'm saying is accurate. What is happening to get from here to here? Well, the first thing that I notice is that it's definitely reflecting over this axis, otherwise I wouldn't be able to get here. I wouldn't be able to get my graph below. But also, this parabolic sort of piece was originally on the right, and now it's going to be on the left. So it actually appears that it's reflecting both over the x-axis and over the y-axis. Over the x-axis to make this point come down, and over the y-axis to make this point go to the left. So I'm seeing a reflection over the x and the y-axis. Let's see what would happen if I did that to my point. If I took the point 2, 2 and I reflected it over the x-axis, that would make this -2. And over the y-axis, that would make this -2. So that would get me to the point -2, -2. And that is not what I need. So what needs to change is this portion here. Something else needs to happen to make this go from -2 to 0. Well, how do I make this go from -2 to 0? I must translate 2 to the right. Let's grab another point and make sure that that works with another point. So let's pick this point and this point, going from 0, 1 to 2, -1. So if I take my F point and I reflect, that goes to 0, -1. That covers both of my reflections. Then I translate, so then I add 2 to my x value, moves this to be 2, -1. So I have confirmed that my transformation is correct. Reflect over the x and y axes, and then translate 2 to the right. So the key ideas in this video. We recapped the types of transformations, both rigid and not rigid. So we talked about translations, stretches, shrinks, and reflections. We talked about high-vo to help us remember that horizontal transformations happen inside the function and are the inverse of what you think it should be, and vertical transformations happen on the outside and are the original, what you think it should be. We then talked about rewriting these transformations, looking at a function, identifying them from the function notation, and also writing them, being given the transformation, applying that to the function. We then talked about how to sketch a transformation on a graph, and we lastly talked about how to identify a transformation from a graph. So go ahead and write down any questions that you have or post them below, and I look forward to supporting you on this. Thanks for listening.